Hello everyone, I am Dr. Millie and you are watching Erudite Chemistry. In last videos of Asparok element, we have learned that all the metals of the group 2 react with the air, with the water and with the halogen to form the oxides and hydroxide and halides type of compounds. In this video, we will be learning only the nature of these oxides, hydroxides and halides. So, nature क्या है, what type of compounds they are, whether they are acidic or basic or they are somewhat other kind of, that we will be learning. So let's understand first of all the nature of oxides and hydroxides. So first of all I am taking oxides and hydroxides. Okay, so what type of oxide and hydroxide these elements form? So first thing is very clear here that all these elements are metals, and just because they are metals, all we know that metal K oxides dissolve in water to form hydroxide. So all the metal oxides are basic in nature. ये तो हम 10th class में पढ़ चुके हैं. So just because these are also metals, they also form oxide which dissolve in water to form hydroxides. A very good example of this kind is that we know that magnesium oxide, when we will dissolve this magnesium oxide in water, it will form MgOH whole twice, isn't it? अगर हम लेते हैं calcium oxide, this will also dissolve in water to form what? Calcium hydroxide. All these are basic in nature because they will dissociate to give OH minus ion, isn't it? Now the next thing is, is there anything which is exception? Yes, beryllium oxide is of that kind of which does not dissolve in water to form hydroxide. Then what? What is the nature of this oxide? Actually, this is amphoteric in nature. क्या इसका nature है? Amphoteric. अब ये amphoteric क्या है? This amphoteric means amphoteric में this amphi term जो है ना, this ampho term is taken from amphi. Amphi means both. Both kind of nature means it is not only acidic or basic. It is working as an acid as well as bases. Means if I react this beryllium oxide with acid and I will react with beryllium oxide with base, acid के साथ base react to form the salt and base के साथ acid react to form salt. But here this beryllium oxide will react with the acid as well as bases to form salt. So let us see what will be formed here. The beryllium oxide react with the HCl to form BeCl2 and water, and NaOH के साथ again it will be forming a salt, and that is सोडियम बेराइलेट. इसका नाम क्या है? सोडियम beryllate. Okay, so again we are getting this salt in this reaction. So what happens when this beryllium oxide reacts with acid? It reacts to form salt in water. Same way, if it reacts with the base also, it forms salt. It means it is behaving like acid as well as it is behaving like base. So neither it is basic nor it is acidic. It is amphoteric in nature. Very important for your exam purpose because most of the time teachers give this question, what is the nature of beryllium oxide? So this is the answer, and you have to show the reactions in both the cases, like both kind of reaction you have to show its behavior. Second thing is, when we go through this oxide of magnesium oxide, all the calcium oxide, because these are made up of plus minus यानी कि cations and anions, these are ionic in nature. And just because this beryllium oxide is, this beryllium out of these two, this beryllium is not having that good tendency to lose the electron क्योंकि ये बहुत छोटा है. इसका छोटा size will not allow it to lose the electron. अब जब ये lose नहीं कर सकता तो it is not going to make ionic compound. So that is why this beryllium oxide is different from other oxides also in the way that it is covalent in nature. But rest of the oxides of this group makes ionic oxide. तो क्या ध्यान रखना है? All the oxides of this particular group metal, these are ionic in nature, जबकि the oxides of this beryllium is covalent in nature. So this is again a very different thing shown by the beryllium. Next, नेक्स्ट इज दैट दिस बेरिलियम, जैसे बाकी के ऑक्साइड्स को वी डिजॉल्व इन वाटर एंड दे फॉर्म हाइड्रोक्साइड, दिस कैल्शियम ऑक्साइड डिजॉल्व इन वाटर टू फॉर्म कैल्शियम हाइड्रोक्साइड। तो ये हाइड्रोक्साइड कैन बी मेड इजीली बाय द रिएक्शन ऑफ ऑक्साइड विद द वाटर। फिर बेरिलियम का हाइड्रोक्साइड कैसे बनता है? बेरिलियम ऑल्सो फॉर्म हाइड्रोक्साइड। वो अलग बात है कि उसका नेचर अलग है, बट व्हाट इज द फॉर्मेशन, हाउ इट इज फॉर्म। तो बेरिलियम ऑक्साइड कैसे बनता है, लेट अस सी। आई एम टेकिंग बेरिलियम क्लोराइड and I am reacting it with water, or I can say that I am hydrolyzing this beryllium chloride. On heating it is hydrolyzed to give you what? BeOH whole twice, and fumes of HCl comes out. This reaction is very important. Here you are getting the fumes of HCl. क्या मिल रही है आपको? Fumes. So most of the time this question is also asked from the students that why beryllium chloride, when it is hydrolyzed it fumes. Why it fumes? Because of the formation of this HCl, because this beryllium chloride hydrolyzed on heating to give beryllium hydroxide and HCl. तो ये beryllium hydroxide बना तो है, but this beryllium hydroxide is basic in nature or not? No, it is not basic in nature. You know that these all hydroxide are basic in nature because they dissolve in water to form what? OH minus, but this is not ionic in nature, so it is not going to dissociate. तो फिर इसका नेचर क्या है? Amphoteric. Again, to remember, beryllium का oxide is amphoteric in nature and beryllium का hydroxide is also amphoteric in nature. Let's see how it is amphoteric. अगर ये amphoteric है तो it will be reacting with the acid as well as base to form salt. So let's see, let's find out कि whether it is reacting with the acid and base to form salt or not. ठीक है, तो देखिए BeOH whole twice. इसकी रिएक्शन फर्स्ट ऑफ ऑल विल बी डूइंग विद, किससे करें? एसिड से करें. दिस इज HCl. ओके, ऑन द अदर हैंड साइड BeOH का होल ट्वाइस वी कैन रिएक्ट विद NaOH. So its reaction with NaOH and its reaction with HCl. What will happen? चलिए, let's see what will be the product form. It will form H2O whole 4 Cl2. This is formed, this is a salt here which is a corrugation type of salt, different salt, and here in this case it will form Na2PeOH whole 4. So this is again the salt is formed. So can you see there, this hydroxide, if it would be basic, it would have reacted with the acid to form salt, but it is reacting with both acid as well as base to form the salt. But just because it is forming the salt with the acid as well as bases, I will call this substance not a basic substance. It is actually amphoteric in nature, which is behaving like acid with the base or base with the acid. So I hope it is clear to you that this beryllium oxide is showing both kind of behavior, acidic as well as basic. Is it clear to you? So this is all about the oxide, the nature of oxides and the nature of hydroxide of this group. Now let us see how their stability changes when we move up to down about this hydroxide. So stability, when we talk about the stability, अब stability में what we talk about is the thermal stability. मतलब अगर मैं हाइड्रोक्साइड को गर्म करूँगी तो whether it will be stable or it will not be stable, that is called thermal stability. So if I talk about stability of the hydroxides or solubility of the hydroxide, or the another thing is that basic character of the hydroxide, basic character of hydroxide. एक एक करके बात करते हैं. अभी एक चीज लर्न कर लेते हैं, समझ लेते हैं. स्टेबिलिटी हो, चाहे वो सॉल्युबिलिटी हो, चाहे वो बेसिक करेक्टर हो, all these three characteristics increases when we move up to down. Increases का मतलब है if I move from magnesium up to down means the basicity of magnesium hydroxide, MgOH whole twice, calcium hydroxide, COH whole twice, all of them will make the hydroxide like BeOH whole twice. Which out of these will be more basic in nature? This barium hydroxide will be more basic in nature because basicity increases up to down. Same way, another thing that is stability, thermal stability. मतलब if I am heating these hydroxides, सबसे कम stable this magnesium hydroxide, और जैसे जैसे हम नीचे आते जाएंगे, the stability of these hydroxide will also increase. Same way, if I talk about the solubility, solubility का मतलब है कि solubility बढ़ती जाएगी. When we dissolve them into the water, they will be easily dissolved. Means magnesium hydroxide, we all know magnesium hydroxide is very less soluble in the water. We can get the basic characteristics because of very less solubility. तो basic character तो ये show करता है when it dissolves in water, it release OH minus ion, but it is not that much very good solubility of the water in the water, but it is soluble थोड़ा सा. On the other hand side, अगर हम आगे बढ़ते हैं ना, calcium hydroxide, strontium hydroxide, barium hydroxide, they are better, they show the better solubility in the water, solubility in the water. और up to down जाने पर, नीचे ऊपर से नीचे जाने पर इनकी solubility definitely बढ़ती है. ठीक है. So this is the way they show the solubility, stability of their hydroxide and the basic character of their hydroxide. So I think it is clear. Now let's talk about the halides, the nature of their halides. We all know that these will also react with the halogens to form halides. For an example, if I react the magnesium with the chlorine, I will get magnesium chloride. Same way, other elements will also form halides. We all know this thing also, that the magnesium has tendency to lose the electron. It will convert into +2 ion. It will convert into -1 ion. So these compounds which will be formed after the reaction of these metals with the halogens, these will be ionic in nature. Okay, so we are confirmed this thing that these are metals, they are good metals, and just because they are good metal, they will react with the halogens to form the halides, और halides जो होंगे वो हमेशा ionic होंगे. But one element is there which is not going to form the halides which are ionic in nature. What is that? Obviously it will be beryllium, because it is not that good metal. So BeCl2, although it is chloride, it is a halide, but it is not ionic in nature. So the nature of this beryllium chloride is covalent. The rest of the chlorides will be ionic in nature. This is first thing. Next thing is, if you move up to down, ionic character will increase. We know this thing that magnesium से ज़्यादा reactive calcium, फिर calcium के बाद strontium, then barium, then radium. So we know this thing that as the metallic character will increase up to down, the ionic character of their halides will be also increasing. For an example, if it is MgCl2, if it is CaCl2, if it is SrCl2 or BaCl2, this BaCl2 will be more ionic in nature in comparison with the magnesium chloride. The reason is simple, that barium is more this is more ionic in nature. This is more better metal it is. That is why it has more tendency to lose the electron. Hence it will make the ionic compound. Is it clear? So this is all about these halides. Next thing is, if we talk about the halides, one more nature we have to understand, that is hygroscopic. They all are hygroscopic nature. मतलब they have tendency to absorb the water contents from the atmosphere and they remain as hydrides. तो they form hydrated molecules. तो अब जब ये hydrated molecule बनाते हैं, what is the proof? They are found as a MgCl2 found as MgCl2 8H2, CaCl2 आपको जो मिलता है वो मिलता है CaCl2 6H2. आपका बाकी सारे हाइड्रोक्साइड्स, बाकी सारे क्लोराइड्स are also formed in the as they are hydrates. तो हाइड्रेट्स की फॉर्म में मिलते हैं. Why it is? Remember that first group elements were smaller one, छोटे थे, और हाइड्रेशन एंथैल्पी जितना साइज छोटा, फर्स्ट ग्रुप एलिमेंट्स बड़े थे. That is why they did not have tendency to make the hydrates. But in this particular group, we know this thing that these group elements are comparatively smaller. First group से छोटे हैं. Just because they are smaller, they have tendency to make the hydrates. तो इनकी हाइड्रेशन एंथैल्पी काफ़ी ज़्यादा नेगेटिव होती है. Although ऊपर जाते जाइए तो हाइड्रेशन एंथैल्पी ज़्यादा नेगेटिव होने की वजह से दे विल बी हैविंग टेंडेंसी टू फॉर्म द हाइड्रेट्स. ठीक है. सो दिस इज द वे दे आर गोइंग टू फॉर्म हाइड्रेट्स. ऑल्दो हाइड्रेट्स की फॉर्मेशन टेंडेंसी जो है कम होती जाएगी ऊपर से नीचे आने पर. इज इट क्लियर? नेक्स्ट थिंग इज विच यू हैव टू रिमेंबर, दैट इज इफ आई टॉक अबाउट बेरिलियम क्लोराइड, BeCl2, its existence is important, that is when it is in the vapor state. In the vapor state, this BeCl2 exists as BeCl2 like this, है ना. जबकि in the solid state, its structure, it comes in the combined form, and many of the molecules stack together, connect together to form a long chain. यानी this form is called monomeric form, अकेले रहने वाली, and the form which is existing in the solid state, that is called polymeric form. Polymeric form, when the structure is repeating itself, connecting with each other, that is polymeric form. So look at this, Be, 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 like this, Cl2, 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 and just because their octet is not completed ना, क्योंकि बेरिलियम की outermost shell में there are 2 electrons, क्लोरीन इसमें 2 के साथ शेयर कर लिया, तो अगेन there are only 2 electrons in the outermost shell, like total 4 electrons are there in the outermost shell, तो 2 plus 2 shared, 4 electrons, तो 4 electrons, how many electrons any of the atom wants in its outermost shell? 8 electrons, तो इस वजह से they work as like they are not satisfied kind of molecules, so they react this way. Look at this. So this way they connect to form the polymers, and these in this form, in the solid state, they form in the polymeric form. So beryllium chloride exists as monomeric form in the vapor phase, and if it is in the solid phase, solid state, it exists in the polymeric form. This is about beryllium chloride. Already I have told you one thing, that beryllium chloride easily can hydrolyze itself. तो beryllium chloride को आप easily hydrolyze कर सकते हैं by simply heating it with the water. और जब ये hydrolyze होगा तो क्या बनेगा? Beryllium hydroxide. Remember that? And fumes will come out. Fumes किसकी निकलेंगी? HCl fumes. ये तो मैंने कहा ही था, पूछा जा सकता है. This question is important, that why beryllium chloride fumes when it reacts with water. किस चीज़ की fume होती है? तो the answer will be that HCl will be formed when it is hydrolyzed on heating. तो ये मत भूलिएगा, on heating it hydrolyzed to form the fumes. Is it clear? So these are the general tendencies which are shown by the halides of this group metals. अच्छा, एक चीज़ I forgot to tell you, that is beryllium, magnesium, calcium, although these all are very reactive metals, और ऊपर से नीचे आने पर reactivity बढ़ती है. But one thing you have to remember, that beryllium, let me write here, beryllium and magnesium, these two metals do not react with oxygen at the normal temperature. The reason is that they form the oxide layer on them, and that is why they do not react with the oxygen at the normal temperature. When you heat them, so definitely we have seen the magnesium ribbon, that experiment of the magnesium ribbon burning, where we have seen that on burning it will give out the energy, but on burning, but at the normal temperature it does not have that much tendency because of the formation of oxide layer. So oxide layer के बनने की वजह से they do not react. Rest of the metals react at the normal temperature. I think now you know that how these metal halides, hydroxides and oxides behave. So in the next video we will learn about oxoacids and the behavior of oxoacids. Oxoacids we will understand first, what are oxoacids, and then we will understand what will be the nature of the oxoacids of these metals.